sorry, I think it's time to say good evening now. Welcome to the last session, this last session of today. Sorry for my voice, I'm extremely nervous after a 3 years break from DevOps. So today I would like to invite you for a small walkthrough about caching, but not only a simple put and get, but something beyond caching and something that can get to some better, more advanced use cases we can do with different implementation of cache. So my name is Jakub Marchwicki. I came from Poland. I work on daily basis in Hazelcast, which is one of the vendors of an in-memory data computing platform, which can do cache, but a few other things. Obviously, Hazelcast doesn't have an office, so I work remotely. That's why my cat is just killing me sometimes. So what I'd like to walk you through, as it's a tool in action, is how we can instrument, how we can implement, and how we can enhance our application so that when it needs caching, it's done correctly and it's done better than usually. But for this to have a storyline, because it's always better when something has a storyline, let's meet James. James is a, let's say, student. And he had this idea for an app. It's not yet unicorn, it's not yet $1 million, but it's quite a fancy gaming app. So imagine you're sitting in a room with a friend and you're a geek, so you don't want to talk with each other, but let's say, hey, let's play something. And you have this app where who taps fastest wins. And that's it. So he has this app. A pretty successful one. And he just did it overnight. So it's a very simple one as well. It has 2 endpoints because obviously it has a REST API. You can tap, and once the tapping is over, you get a leaderboard, and it's all down to the SQL. I think even though it's just a tap and it's funny, we kind of recognize this pattern. So yeah, we have this tapping. This was backed by the SQL with very profound advanced queries in the only successful 4th-generation language ever. So in SQL, we had to insert something into the database and then select query. We have some aggregation. That's it. Simple as that, as long as they were playing in a single room. It was okay. We can even drive a diagram for this application. There was a user, the user was tapping, everything was just smashed into the database. That's it. And well, when they say if something's stupid but it works, it ain't stupid, so it wasn't really stupid. We could either derive a classical archetype of application architecture, 2 boxes and a cylinder. That really worked, and God looked at this architecture and said it was good. Jokes aside. The beauty of this kind of application is when it comes to code, it's simple, non-verbose, easy to reason about, easy to comprehend. So our tapping service, which was kind of orchestrating all this, was just throwing data straight in the repository. Yeah, so God looks at the implementation and said, yeah, it was good. But one day, James' colleagues figure out that it's a really cool app, and they all started playing in the dormitory, and James had a problem. His app stopped working, so he started to think, what can I do? And obviously he decided to cache all the things because he didn't know this real proverb that cache invalidation and naming things are the only 2 things in the computer science. This is a real thing, and somebody really said that. But in Netscape times. I don't know if anybody here used Netscape Navigator as a browser. Yes, so there are a couple of classic guys. Yeah, I use Mozilla. Ha ha ha. Yes, but let's get to the presentation. So James thought, if I start pushing stuff into the cache, it might look more or less like this. So I'll have my code, and my code will put something into the cache, and just for security reasons or just to be on the safe side, I'll put it into the database as well. And if I were to query it, I can query it directly from cache. The app will be faster. I think you recognize this pattern. Yep, that's how usually how we work. The problems start to arise when we look into the code. Here, concurrent hash map is just good enough representation of a cache. We'll drill down further. It can be caffeine, it can be Guava cache, whatever. But the problem that arises is that within our code, we have orchestrating cache, and we have orchestrating repository. We have to do kind of two things at the same time. Kind of small, kind of source of problems. But what James started with was a good enough or first approach towards caching representation. It's called cache-aside pattern. Obviously, caches do have patterns. Everything has patterns. So we have code, we set stuff to cache, and we store it to the database. And when we query gets a little bit more complex, we try to get stuff. We try to get stuff from cache. If it's not there, we try to look up the data store or our storage persistence. When it's there, we set it to the cache and then return. Sounds good enough. And anybody can read it. That's kind of easy to understand, easy to comprehend orchestration flow. That's a good. But at the same time, our code starts handling two responsibilities. It orchestrates the flow of the application and also orchestrates the pattern. And we start to have problems. What's the source of the truth? Is the truth in my cache or is the truth in my storage? And what if something goes off? Where should I take the data? And usually that's something obvious when people start working with distributed systems, but until they don't, they never know what is the source of the truth. The cache-aside thing also brings us to different problems or different kind of problems because our architecture looked like this. We had a single instance of our service, of our backend, and it was a database. And once things get slower on the application side, we can't really go from this to this. We can't start scaling up our backends. We can't scale out our application services because our application services are no longer stateless. They keep some state. It's a kind of a view of a database or a view of a subset of the database in terms of a cache. So we got a problem that we can't go AJ, we can't be highly available. We have independent caches on each of the nodes. That's how Caffeine works, that's how Google Guava Cache works. And we keep getting this inconsistency between cache and storage. Not talking about orchestrating the business, well, mixture of orchestration and business code within our application. That's not something me as an engineer or me as a programmer would like to see in our code. So what we can try to do is, instead of having a view of a subset of a database, meaning cached data, on our application, we can put something externally. We can have a client-server approach and put something next to our database and keep cache data over there. And that's fairly popular approach. But again, that doesn't come without any problems. So we kind of mitigate the problem of high availability because we can scale out our services, and we don't have independent or different view on the data on each and every node. We still have inconsistency gap between cache and the storage because these are two different things. We still mix up different code in our application, and we get two more things to handle. We have a separate hardware component which we have to manage, and we are starting to hit a distributed transaction because we would like to have atomic right to both cache and storage, which we know as software engineers and computer scientists by craft that is fairly impossible, or impossible, depending who you ask. So, what can we do now? Because I have a feeling that trying to address some problems of the initial very simple or simplistic cache, we are getting into more and more problems. Obviously, some of the caching or some of the vendors, probably including Hazelcast, will tell you, well, setting up hardware is not a problem, but whoever tried to manage a cluster of Redis or Hazelcast knows it's not an easy thing. So what we are trying to achieve now is we are trying to address these two boxes. The way we initialize or set up our caching platform, and the way we orchestrate the data between our application, storage, and cache. And this is source of many, many issues when it comes to boosting up performance of our app. If caching or low latency access to the data is really a problem. I will not tackle that, but if it's really a problem. So let's get into details. So we have 4 problems to tackle. We have this inconsistency gap, which we would like to, which the moment we start using simple put and get, starts kicking us. We have infrastructure code in our application. We have a distributed transaction between 2 independent hardware, 2 independent storages, and we have yet another hardware or the application to manage. We can say managing hardware, we can go to the cloud, let's say we get a managed service. The 2 others, inconsistency gap and the distributed transaction, we can somehow mitigate it through another pattern, which is read or write through pattern. And the mixture of infrastructure code with the business code, we can address it through unifying the layer of storage. How to do it, I'll show it in the next steps. Cloud is obvious. When we go to AWS, it has Elasticsearch. Obviously, Hazelcast, it has its own offering. GCP has memory storage. Every vendor pretty much has a cloud offering. I'll not drill it down. So let's say we have this one crossed out. What is read-write through pattern? So what we are trying to do now is we would like to delegate operation of writing down data to the storage, to the persistent storage, to the cache itself. So whenever we put something into a cache, it will write itself down to the storage. And at the same time, if we try to get something out of the cache, cache will manage the life cycle of data which is inside and retrieve something from the storage if needed. Sounds fairly obvious. And to be honest, when it's done correctly, it's pretty obvious. What it gives us, we don't have to think about how this orchestration code looks like within our application code. We kind of delegate it to a caching layer. Because our simple example, when we have 2 lines of code, one about writing or merging something with a cache layer and then persisting something into the database, was having this kind of this kind of a twist, because in that code you've seen on the screen, there was nothing about retry policies, about handling errors, about connection errors with the database or with the caching layers. We kind of ignored it because it's not needed for the presentation, but in real life, that's becoming a problem. What if you cannot write down something to your storage? Whether you retry, whether you send back acknowledgement once it's written down, or maybe you give yourself some slack, depending on your use case. This is something you have to think about when designing the code that is orchestrating this all cache. So in here, we clearly can separate the concerns. We have a code that interacts with we have our code that interacts only with the cache, and there's no infrastructure plumbing code. The infrastructure plumbing code is delegated yet to another layer. That's kind of makes certain things easier. So when we had this topping service, I consciously put some caching implementation on the top because we don't really care what implementation we will do. So what we want to do is we want to replace it all by something like this, that whenever I try to store something in the cache or do any other operations which are not shown here, the caching layer will persist it further into the application. So on a Hazelcast, there is a concept of there is a concept of a MapStore, which is a class that you can implement that will instrument working with your database that is tightly coupled to the life cycle of your entities on on your in your cache, and depending what you do, so whether you retrieve data, whether you clear data, whether you update data, it populates it down to the persistent storage. Other vendors obviously have the similar functionality as well. So this is one of the implementations. That covers the read-write-through pattern and slightly covers the mixture of infrastructure code with the business code. So now in your code, instead of talking to both repository and a cache, you just talk only with cache. And some people get anxious about that because they say, hey, I was talking to my, let's say, Oracle, Postgres, whatever database, and whenever I've written the data down, I was sure that it was there. Now you want me to talk with some other technology that will assure me that at some point in time, or once I write something down to the cache, it will be populated further down to the database. Some people are uncomfortable with that. Some people are uncomfortable with the different fact that they have to implement cache or to introduce caching into their application, they have to start fiddling with their application logic. And usually when people have a concept, I will put cache inside or in front of my application. If I put cache inside my application, it means that most probably the app has a meaningful age. Most probably people don't really want to invest in that much more. They don't want to touch it. It's mostly like, well, if it works, don't touch it. And they feel very anxious or not really keen on changing something within the app. So they want to go with minimal changes within the app and to get what they want, so to get this performance boost of retrieving the data. So what you might start looking into as well is you just had a simple repository in the past. Your service was just talking to a repository, and now you start introducing this different layers or different code to orchestrate with yet another technology. What you might start looking into is, can I have a caching layer? Can I talk with a caching layer directly in SQL? My repository I was using SQL just to put the data into the database. Can I use the same language to access the data from SQL? And some cache providers obviously support it. Hazelcast obviously does it. So I had two different queries. I have something to insert, and I have a more advanced aggregation that I was about to query the data from my cache. So what I would like to do now is I would like to keep the same language. I would like to keep the same protocol, but replace the implementation. So let's say my SQL repository was a very simple JDBC template. And I was using JDBC template, and when I started, just to show you that it's a really database, I was creating a table if it didn't exist. Well, yeah, I was creating a table if it didn't exist, and the table had a very simple structure. And based on that, I could insert and query data. So what I can do as well, I can introduce a different layer, or instead of SQL repository, I can introduce a Hazelcast repository. Hazelcast has a module called JDBC, so we can talk with a Hazelcast over JDBC from whatever application. That lets you just to create a mapping. We don't have tables, we have mappings, because that's the difference. And from now on, when you define where you are querying the data, everything else look the same. So you can query, retrieve, and insert data into your application in exactly the same way as you did before. So you can look for ways to have this more advanced use case, like read through or write through within your cache, and still minimize the amount of changes within your application. That's very useful when you're using some older legacy stuff. So that tackles pretty much the the basic concerns. So what's the crux? So where's the fancy stuff? Key value store is pretty much a commodity and no one brags about it. When you go to more advanced use case, the problem is becoming that if you go to AWS and would like to implement something like this, you can't really do it. You have to do it on your own or your own implementation, for example, Redis. If you would like to go to the cloud that supports only Memcache, you can't really do it. So what I would like to show you now, within, let's call it 5 minutes, we have this thing in Hazelcast called Viridian, which is pretty much Hazelcast in the cloud, a managed version of the Hazelcast cloud. And I would like to show you that you can really go and play with a MapStore implementation just within 5 minutes, because that's as much as I have for the presentation. So what I'll do, no, I'll go like this. Okay. I have the. Yes. So this if you go to viridianhazelcast.com, you have a console and you can then create a cluster, and it's all real time. So you can create a production cluster, which is a multiple members, highly available cluster, or if you're just playing around, you can create a development cluster. Development cluster is just a single instance, but it's optimized for fast iteration. So I create a cluster. It's all running at this point in the AWS. It takes about 20 seconds to start. On the top of that, okay, so it's available. I can go to my cluster and I can download some sample codes. What we are doing is we are generating a sample application that helps you interact with the cluster. I will start with that. Okay. Ooh. No, it's not working. It comes in a zip, so I'll just unzip it. And it comes with a very simple app. It comes with all. It's kind of predefined in terms of connectivity. All the passwords are pre-filled, or the security, and so on and so forth. And we'll play a little bit with just a simple view of putting data into a cache. But before I do that, I said I would like to have whatever I put in my map or whatever I put in my cache. I will just put cities with population, fairly simple data. I would like to be automatically populated or automatically saved to a database. Just to show you that, I have another thing. That's an Elephant SQL Cloud PostgreSQL, where I have a single table called cities, which is empty, as you can see. And what I will try to do now is I'll have a very simple implementation of a MapStore, which I'll deploy on the cluster. And once I start interacting with the data will get populated into the database. It's just to show you that a fairly complex use case, like storing data into the separate data store, can be achieved very quickly and in a fairly playful way. So I have this implementation of a MapStore. Implementation of a MapStore in Hazelcast Word. That's a test. That's not this one. It's just implementing the interface, MapStore. And then within this implementation, I get a couple of methods like store all, like delete all, and so on and so forth. So the problem is usually that you have to take this code and deploy it somewhere else to the cloud and have it working. And we know that it's very fairly problematic. So we got a Maven plugin for that. So if I package my code so that it comes with a single jar, I can deploy it to my cluster, and it ships the whole jar file, and then reloads the cluster so it's ready to use this MapStore. Obviously, that's all in Hazelcast terms, but as far as I remember, Redis supports a similar operation. it's always up to you to choose. Okay, I'm done with that. So now I can get back to my cluster. So this is my running cluster. And this stopped showing something. Oh, come on. Damn it. Oh, yes. So I have some custom classes already deployed. As you can see, there is a sample MapStore already here. I don't need that anymore. What I need is I need to define now a data structure that will use this implementation of a MapStore. So we'll use this code to persist the data further. So I have my map will be called city. I have to define it. Let's disregard the other configuration options. And now I have to choose my MapStore. So I say, this is my MapStore implementation. So this is the code that you just seen. I've uploaded, and I have to add a couple of properties that will tell my application where is the where is the database and what are the credentials and so on and so forth. So this is my URL for the database. My username is, you will now see my password, which is totally not secure in terms of whatever compliance, but I'll just delete it after the presentation, so worry not. And it's free plan anyway. So I have to define the this one. So now I have defined a map, which is called cities, with a MapStore and with all parameters, and I've saved this configuration, and I have a map running, a code already running in my cluster. You can upload whatever code. Hazelcast allows you to pretty much do computational stuff on the cluster. So what I'll do next is I've downloaded this sample client with all the cities, and what I'll try to do, I'll just run it and see what happens. So I'll do Maven with SSL, and this is all predefined code just to let you start playing with more advanced caching use cases. So I populate countries, there is a SQL, I populate cities, there is a map, and I've entered some data into a map, and it's there, it's in the custom code. Let's see whether it's really got into the it really goes to the Elephant SQL browser. Yes, it's exactly the same. So you can see my country data and city data got populated into the database. And if you don't trust me that it's really in the Hazelcast itself, when you're using a Hazelcast, you can also open a management console. If you are familiar with Hazelcast, Hazelcast has this concept of management console, and it has a SQL browser, so you can go and execute a query, select from the city, and this is viewed directly from this Hazelcast. So you can use the same SQL language to get data out from your Hazelcast, to populate it through to the database, and have a more of a unified view from your application and where your data lives. Now I need to get back to my presentation. That will be somehow problematic. I'll put like just a final word. Oh, come on. No. Slideshow. Not slideshow. You know, we programmers are smart sometimes, but sometimes technology kills us. Yes, that's what's supposed to be here. So that was Viridian, a word of wisdom for the end. So we had this simple cache aside pattern which is where the application is responsible for caching and orchestration layer. We can do more advanced situation with read-through, write-through. We can go even further with write-behind. We don't need our MapStore to go synchronously to the database. We can do some batching. We can do some advanced use cases. And if we are really fancy, we can do things like refresh ahead, so we can orchestrate our caching layer to do some additional computation and provide additional information to us. That's all for me. It's exactly half an hour. Thank you very much. If you have any questions, I'll be around because there's no other talks to attend anyway. Thank you very much.